was at the University of Arizona, and Dr. Adiraja was telling his math story at an event, and so that's where the inspiration came from, and that took me down a Google rabbit hole where I learned that September 25th, today, is National Math Storytelling Day, and it was invented by an online blogger, Maria Droujkova, who her and her daughter co-created the event, which is the sweetest thing I've ever heard, and also the nerdiest thing I've ever heard. So I'm not sure of this, but we may be one of the first, maybe the first university to be putting on a national math storytelling event. And so just take a second to give yourselves a round of applause to being a part of that. So we're hoping that this event, you can help us at the end of this. We're going to give you an opportunity, staff students, this is how you get your extra credit. We'll give you an opportunity for you to give us feedback, be a part of helping us bring more voices to this stage. Thank you for being a part of this, and I want to name that it is an imperfect event where we can't possibly bring forward all of the wonderful stories that could be told and like really represent who is doing math and for what reasons. So if you think of a storyteller that you're like, I would love to hear that person tell their story, be a part of helping us find folks for the next Tangent 2.0 this time next year. So I'm going to introduce our first storyteller. Dr. Karina Salazar is an assistant professor in the Department of Educational Policy Studies and Practice in the College of Education. Her research program uses applied quantitative methods to analyze whether the enrollment management practices of public universities undermine access for underserved student populations. She is co-principal investigator in the Enrollment Management Recruiting and Access Research Project, which investigates admissions recruiting practices of colleges and universities. This work has been featured in the New York Times, on NPR, CNN, Inside Higher Education, the Chronicle of Higher Education, Forbes, and the U.S. News and World Report. Dr. Salazar is a local Tucsonan and proud graduate of Sunnyside High School. She holds a bachelor's degree in journalism and completed her graduate work here at the University of Arizona, where, which was funded through, her research was funded by the American Education Research Association. Please give a warm welcome to Dr. Karina Salazar.
Hello everyone, good afternoon. As Terrace introduced me, my name is Karina Salazar. I'm actually a 3-time alumna of the University of Arizona and now an assistant professor in the College of Education. And so I use applied statistics to study college access. College access refers to the ways in which colleges and universities, as well as federal and state policies, ensure or strive to ensure that all students have an equal and equitable opportunity to attend college. And so statistics is often considered the science of uncertainty. So we often have to make really important decisions under uncertainty. Some examples include forecasting the weather, emergency preparedness, political voting polls, predicting disease outbreaks. These are all examples of the ways in which statistics help us to make important decisions and predictions under uncertainty. In education, we often use statistics to investigate whether smaller class sizes can improve student learning, whether attending preschool as a young child is related to long-term educational attainment. In higher education, we look at just offering financial aid, increase college completion for students. And while statistical methods can't eliminate uncertainty, they can help us to see or to gain some type of knowledge despite it. They help us see patterns through uncertainty, and they help us to quantify that uncertainty to see whether or not the patterns that we observe are real or if they are occurring just by chance. This is the idea of probability. The higher probability expresses a higher degree of certainty that something will happen. Statistically speaking, I didn't have the best probability of being where I am today. You see, in education, we often think that parental education, your socioeconomic status, your race, ethnicity, where you went to high school are some of the best predictors of whether or not you will attend college and whether you will complete college. I am the daughter of a Mexican immigrant that came to this country with a middle school education. I grew up in South Tucson, which is one of the predominantly poorest and Latinx communities in the city. And I was an English language learner. I didn't become fluent in English until about the 3rd grade. And I also attended a high school where less than 40% of students attend college, many of which begin at the community college level. And of the students that do make it to college, only about 7% persist and receive a 4-year degree. And so I didn't start off my college career much in the way that I expected to. I came to the University of Arizona, and despite doing well in math courses throughout high school, I didn't place into college level math courses. I took the exam during orientation. I thought I had done well, and I didn't. So, determined to not allow this to limit the majors that I was selecting, I decided to spend the summer between high school graduation and entering the university, taking remedial math classes over at Ewinghill Community College. I spent the entire summer taking those classes. I thought that I would be back on track once I started the university, and so I enrolled in a pre-calculus class that first semester. And that first semester of college was probably one of the most defeating experiences of my entire educational career. I remember I worked so hard in that pre-calculus class. I sought tutoring help, I went to exam study sessions, I worked really hard, but despite all this, and despite doing all the right things that you're supposed to do, I still just ended up with a C. I struggled to keep up with the pace of the class. And so, completely discouraged with this grade and how I had done everything right, and still I ended up being kind of having a C grade in this class, I completely did not take any more math classes. For better or for worse, I decided writing was my strong suit, and so I took more writing classes. I declared a journalism major, and I started writing for the Daily Wildcat, which I was assigned the education beat. Through these experiences, I became really interested in investigating educational inequity and policy as a student journalist. I was assigned to cover HB 2281, which is the law of the Arizona law that banned the Mexican American Studies program over at Tucson Unified School District. I was covering stories on changes to state funding to K-12 systems. I was editor-in-chief in reviving a 1960s Chicano newspaper that focused on understanding the issues impacting the education of Latinx students here in Tucson and at the university. And so after graduating college with my journalism degree, I decided to pursue a master's degree in higher education. And so I'm a first-generation high school student, I'm a first-generation college student, and so you can imagine how nervous I was entering a graduate program. I didn't know a thing about graduate school. I didn't know what it would entail, what would be expected of me, and I come to find out that my program required an introductory course to statistics. It was my worst nightmare. I thought my first semester of graduate school is surely going to turn out just like my first semester of college. I'm going to take this class, I'm going to be so discouraged, and then I'm going to have to change my plans all over again. And so, despite my anxiety, despite thinking that I would fail this class miserably, I did okay. But more importantly, I really enjoyed the class. And I think the reason why I enjoyed it was because I was applying mathematical concepts to understanding real world problems and real questions regarding something that I cared and I valued very, very deeply. It was education. And so learning statistics became this very empowering moment throughout my education career, both professionally and personally. And so after that first class, I never stopped taking statistics courses. It's certainly not an easy road. It was very difficult. I still struggled. In fact, I took that introductory course twice. Although I did fine the first time, I found that it took me a really, really long time to understand a lot of what I was doing. I found that I could easily get the right answer. I was just following formulas, I was plugging in numbers, I was crunching these data. I could get the right answer. I did not understand what that answer meant. I didn't know how to apply that answer to solving real-world educational problems. And so I continued to take I took just about every applied statistics course that was offered at the university. And I actually moved across the country, and I went to the University of Michigan during my last year as a PhD student to take classes in causal inference, which is the statistical methods branch to study the effect of policy. And so I also sought out opportunities within the university to be able to work in institutional research offices and assessment offices, to be able to apply a lot of the technical skills that I was learning in class to real-world problems with real data, with real students. One of the first assignments that I received in those offices was to evaluate the S4S program, to see whether or not this program was actually helping students that didn't test into college level math become successful throughout their college career, regardless of whether or not they decided to go into math. So ironically, this event is kind of coming full circle. And so, my motivation behind learning statistics, although it was a long and difficult journey, was always that I wanted to change the way that we talk about college access. I realized that quantitative educational research, statistical research, holds a lot of water when it comes to thinking about educational policy. And mainstream policy discourse about inequalities in college access always highlight explanations that place the burden on students, on families, and K-12 schools. According to these explanations, the odds, the probability of me graduating from high school, of me attending college, of attaining an advanced degree, of becoming a tenure-track professor were low. According to these explanations, I was an exception to the pattern. I was an outlier. And so in statistics, we think of outliers as these observations that appear to deviate substantially from other observational patterns. We often dislike them because they tend to bias our estimates by either overestimating or underestimating the average patterns in the data. In most contexts, we tend to attribute outliers to some type of measurement error that we need to deal with because they occur just by random chance rather than being indicative of actual patterns in the data. But what I realized is that statistics isn't just about numbers, it's not just about averages, it's not just about general patterns. And outliers here are deeply important because they tell stories. They speak a truth that makes us question and be critical of what we believe to be occurring just by chance. And so I drew on my own experience as an outlier to study college access from a very different perspective. Rather than attributing the underrepresentation of students like myself in college to their family background, I investigate how some of the biggest barriers to college access for low-income students and for students of color are the actual admissions practices of universities themselves. And so here's the beauty about outliers. Outliers push against patterns that we believe to be certain, that we believe to be significant. One observation that deviates from the pattern is just an outlier. But with enough of us, we begin to skew what normal looks like. We begin to skew what that pattern is. And so we skew the odds in favor of our own success. Thank you.